All right, we're starting our pre-algebra Unit 4 proportional reasoning worksheet number 1. Which of the following lists in order are from smallest to largest? So the first step is to change each of these to a decimal so we can tell which one is smallest and largest. Okay, so first I want you to do this. I want you to write out each fraction and then even the percent, and we're going to show how to change this to a decimal. And then this is already a decimal form, so we didn't have to convert it. All right, to change fractions to decimals, all you do is divide the numerator 1 by the denominator 5, and the decimal for 0.5 is 1.5 is going to be 0.2. Okay, and then 2/11, 2 divided by 11 equals 0.18. We'll round it to 0.18. This one already was a decimal. And to change percents to decimals, all you do is divide by 100. So 17 divided by 100 equals 0.17. And then what you do is you take the largest decimal and you make everything else match it. So you add on zeros. Since this had 3 decimal places, I'm adding on zeros to make each of these have 3 decimal places. Okay, and from this we could tell that the smallest is 17%. Then the next one would be 0.175. And then next would be 180, which is 2/11. And then the next would be 200 thousandths, which is 1/5. So this is the answer from smallest to largest, and we figured it out by changing these to decimals. So write that out. Okay, problem number 2. A certain paint is to be mixed with 4 parts yellow to 2 parts blue. 12 gallons of mixed paint are needed. How many gallons of blue must be used? On this one, we want to do a proportion, but the problem is we can't just use 4 and 2 because we don't have information for 2 yellows. They have 2 parts blue, and then here's the question, how many gallons of blue? So you could put 2 blue, and then how many gallons of blue here. The other thing that we have for both problems is the total. We have the total. See, this numerator was blue paint, and the denominator is total paint. So 12 gallons are needed. The total over here is 12. And the total over here is just add 4 and 2. You know the total on this side is 6. 4 parts yellow, 2 parts blue. Together that makes 6. Okay? So to solve this proportion, you're going to cross multiply and then divide. This is how you're going to solve almost all the proportions in this study guide. So 2 times 12 is 6. No, not 6. 24. Get it straight. And 6 times 1x is going to be 6x. The unknown should probably be identified with a letter x, so I'm going to erase that. Put x. And then to solve, we have to divide both sides by 6. This 6 cancels out. This 6 goes into here 4 times. X equals 4. Okay, so remember that only use, in a proportion, use what is mentioned twice. It kind of was tricky because they didn't tell you this was the total, but you can figure out 4 and 2 together. The total is 6. So the total on this part of the sentence was 6, and the total on this part of the sentence was 12. The blue parts in this sentence was 2 parts blue, and then the blue part in this sentence was unknown. or x. Anyway, write out this proportion. 2 over 6 equals unknown over 12, and then solve. Okay, for number 3, they want to know the smallest unit price. To do that, we're going to have to divide. Okay, so I wrote out what we're dividing. We're dividing the price by the quantity. This one already has the work complete. So 219 divided by 4 equals 54. We're going to round this up to 55 cents. Okay, 55. All right, next we're going to divide $3. You don't have to put this 0 by 5. And this is 60 cents. When it only has one decimal place, you add the 0 on to make it and then the last one is 350 divided by 6. You can be doing this also. I want you to be writing all of this out that I am writing and working it out on your calculator. Okay, this comes out to 58 cents. You round it. So the smallest unit price is 55 cents per unit. Or 4 items for $2.19. Okay, problem number 4. A $95 graphing calculator is on sale for $85.50. The percent decrease is blank. All right, to solve a percent decrease, first you need to subtract, and then you'll need to divide. Okay, what are we subtracting? We're subtracting the original price and the sell price. When you subtract those two, you get, let's see, 95 minus 85.50. $9.50 or 9.5. Okay, then you divide. What are you dividing? You're dividing the discount by the original price. Make sure you're writing this down. So the discount divided by the original price is 0.1. This is the decimal form of the percent because 0.1 as a decimal is 10%, which we see over here. What did I do here? I multiplied 0.1 times 100. That's how you change a decimal to a percent. You multiply it by 100. Oops. There it is. 10. 0.1 times 100 is 10. All right, so remember what you're subtracting. You're subtracting the original price by the sell price. And then what are you dividing? You're dividing that answer, the discount, by the original price. You'll get a decimal answer, but just convert that to a percent. I don't know why I did that. And that gives you your answer. Okay? Write this out. Okay, problem number 5. What is the length of side X? This tells us that shape ABCD is similar to shape EFGH. They're just flipped. So what I'm going to do is write it flipped. All right, so if this were to flip over the same way this one is sitting, this one's sitting upside down compared to this one, it would look like this. EFGH, where the 0.4 would be on the bottom and the X would be on top. Why did I flip it? It's because you're going to have to write a proportion for this problem, and I want you not to be confused by where the numbers go. Okay, so this shape has 1.8 over 1.2, and if we want to compare it to this similar shape, then we also need to put x, the top, over the bottom, over 0.4. If we would have left this shape the way it was, you probably would have been confused to put where to put your numbers and your variables. Okay? So now that we have them in the right order, we can cross multiply, remember that step, and then divide. So, what is 1.8? Whoa, where did my calculator go? 1.8 times 0.4. 0.72. And 1.2 times x is just 1.2x. All right, and then to solve this problem here, we divide both sides by the number closest to the variable, 1.2. That would cancel that out. And this would become 0.6. So x equals 0.6, or x is, with confidence, x is 0.6. All right, problem number 6, 15% of 25 is what? Do you remember this in the unit? Percent over 100 equals is over of. This should definitely be memorized because you used it a lot in your unit, and you're going to use it on the test quite a bit too. So our percent is 15. 100 stays the same. Our is looks like it's unknown. I don't see, well, the equal sign is. So there's a blank there. That will be our unknown, and our of is 25. And now that we have the proportion set up, all we have to do is cross multiply and divide. 25 times 15. Take off the last problem. $375. 100. Oh, hold on. I just realized that I have been skipping a step, so this might be confusing to you, but the reason I'm getting 100x on this side of the equation is because what you do is you cross multiply these numbers and you cross multiply these numbers like that. That's where the 100x is coming from. But eventually you're just going to end up dividing, so that's why I've been saying cross multiply, divide, cross multiply, divide. This little step right here, though, has gotten skipped. Anyways, so 375 divided by 100 is 3.75. So then x equals 3.75. Okay, and make sure you're writing this out on your study guide. Yeah, every step. Looks like problem number 7 is also going to be a proportion. If on a scale drawing 4 inches represents 64 feet, then 3/4 inch would represent how many feet? So we're going to put 4 inches over 64 feet will equal 3/4 inches over how many feet? Well, to make this easier, of course, we need to change that decimal to, or that fraction, to a decimal. So 3 divided by 4 is 0.75 or 75 hundredths. That will be our numerator. And then the unknown is your variable. Okay? So, and instead of writing it all out like I did here, and I put 100 over at, or made it 100x, we're just going to cross multiply and then divide to solve. I'm not going to write all that out. All right, so 64 times 0.75, 48, and then what are we dividing by? 4. Divide that by 4, 12. So x is 12, or that missing piece is 12. All right. Problem number 8. Which proportion would be used to solve for the height of the tree? All right, so what we have in this image is 2 triangles. This big one that measures the height of the tree, and then the baseline is 40. And then this small one in here, the height of that triangle is 6 and the baseline is 10. So they did that they gave us a smaller triangle so that we can make a proportion. I would have written it like this. Now, they didn't write it like this over here, but we need to find the only way to mix it up. So, these problems have 30s in them, so obviously they're not our answers. We don't have a 30, we have 40. It's a toss-up between these two. On this proportion, they put 6 over 10, okay? So they're putting the height over the baseline, and then 40 over h. Now, this is where they messed up. If they're going to put the height over the baseline in this fraction, they also need to put height over baseline in this fraction, which is not what they did. So it cannot be this one. All right, here they put 6 over h. Okay, they didn't put height over baseline, but they did put height over height. Well, that's fine as long as they do the same thing over here with the baseline. This baseline, yes, of the smaller triangle over the baseline of the larger triangle. So this would also work as a proportion. Each of these will give you the same answer. Do you know that? This is going to be 240 divided by 10, which is 24. This is also going to be 240. 240 divided by 10 is 24. So you can mix up your proportions. Just make sure you're consistent. If you're going to put h over 40 of the larger triangle, then on the smaller triangle, you need to put 6 over 10. If you're going to be putting the heights, 6 over h, in that order, then the same order needs to be used on the second fraction, the baseline of the smaller triangle over the baseline of the larger triangle. Okay? Confusing enough? Okay, problem number 9. Convert 15 meters per second, so that's like saying 15 meters per 1 second, to kilometers per hour. Now, there's not very many numbers given in this sentence, so we're not going to use a proportion per se. What we have to do is convert meters to kilometers and seconds to hours, and then we'll have this part figured out. Do you remember how to convert meters to kilometers? Remember this conversion chart? King Henry doesn't usually drink chocolate milk, where this is kilo, hecto, deca, unit, deci, centi, milli. All right, so meter would be the unit, because the unit is meter, liters, or grams, whatever unit you're working with. We're working with meters. Change it to kilometers. Okay, the decimal will have to go to the left 3 spaces, or 3 placeholders. So 1, 2, 3. So it's going to be 15 meters is 0.015 kilometers. All right. Now, here's another tricky one. Seconds to hours. Do you know how many seconds are in an hour? Well, we know that there are 60 minutes in an hour, right? But that's not seconds. All right, so how many seconds are in a minute? 60 seconds are in a minute. So to figure out how many seconds are in an hour, we have to multiply 60 seconds times 60 minutes, which is 60 times 60, 3,600. So 1 second, 3,600. There's 1 second. Okay, there are not 3,600. Oh, I didn't write that down. There are 3,600 seconds in an hour. So you're not going to write 3,600 here because obviously 1 second is not 3,600 hours. 1 second is 1 out of 3,600 in an hour. Okay? So 1 out of 3,600. A second is, compared to an hour, is 1 out of 3,600. Confusing? I know. I hate this problem. Okay, so we converted the 15 meters to kilometers, 0.015. We converted the second to hours, 1 out of 3,600. This fraction I'm going to convert to a decimal. Okay, so let's go 1 divided by 3,600. Oops. 600. 0.000277. All right. 0.000277. Okay, very small numbers. That's why this problem is so hard. All right, so to get the whole number that they have over here out of this fraction, 0.015 kilometer per 1/3600th of an hour, we've got to divide. Again. So kilometer, 0.015 kilometers divided by, well, I have the number right here, 0.02777. 7777. It goes on forever. This will give us an estimated, close enough answer. 0.54. Which is the wrong answer. Well, looking back at my history, I can see where I made a mistake. I divided the 0.015 kilometers by 0.02777 when it was 0.0002. So, anyway, let's try that again. Divided by 0.000. Okay, there it is, 54. Approximately, since that was a repeating decimal, 50 meters per second, we converted that into kilometers per hour. 15 meters is equal to 15 thousandths kilometers, and 1 second is equal to 1 out of 3,600ths of an hour, which as a decimal is 0.0002777. Now that's not the answer they want. They want this divided by this. That gives you kilometers per hour. All right, problem number 10. A shirt is on sale for 20% off the regular price. The regular price is $25. What is the sale price? Okay, so my question first is, what is 20% of $25? See, if we can figure out what 20% of $25 is, then we can figure out what the sell price is. Now, if you know your 10% rule, you know that 10% of 25 is $2.50. Double that and you get 5. But I'm going to go ahead and do the percent over 100 formula equals is over of, since that's what you've been learning. All right, 20 over 100 equals the variable over 25. Okay, cross multiply and divide. Let's see here, 20 times 25 divided by 100. See, there it is, $5. So all we have to do is subtract $5 from this and we'll have our sell price. 25 minus 5 is $20. So the sell price, $20. Okay, problem number 11. Which of the following is a proportion? To test a proportion when you cross multiply, they should equal. Okay, so this one's not a proportion because 2 times 25 is 50 and 5 times 4 is 20. All right, here we go. 36 and 9 times 4 is also 36. There we go. That's our proportion. Let's just make sure they didn't put 2 in here. 18 and 32. Nope. 60 and 70? Is that what that is? Oh no, I'm way off. 90. No. All right, so this is how you check a proportion. You cross multiply. If those numbers equal, then it is a proportion. Problem number 12, true or false? A direct variation does not always go through the origin of the coordinate plane. We learned this. A direct variation is what? Always straight line. Always goes through the origin. Okay, remember that. Always must be a straight line and always must go through the origin. So this is false. Problem number 13. Which of the following is the best estimate for 51% of 19? So, estimating this to 50%. Hold on, we got a stray hair here. And this, what would we round this to? 20, right? So what is 50% of 20? All you have to do is multiply. Change 50% to a decimal. This is easy though, right? We know what 50% is half off. Half off of 20 is 10. But we're going to go ahead and make this a decimal. 0.5 times 20. Okay, 0.5 times 20 is 10. Yeah. So that's the best estimate. Sometimes you don't know how to get exactly 51%, but if you round it to 50, that's close enough. Round that to the nearest whole number, that's close enough. So 51% of 19 is going to be close to 10. Problem number 14, turn the page. Question says, Sam wants to leave a 15% tip for his dinner. The bill is $19.50. Which equation could be based to find the total amount that Sam should pay? Okay, so what Sam needs to know is, what's 15% of $19.50? Well, then you'd assume it would be this problem right here, right? 15% is 0.15 times 19.5. But let me show you what that gives you. It gives you 0.15 times 19. $2.93. Okay, so is that the total amount that Sam needs to pay? $2.93. Well, that would be nice, huh? But no, that's not the total amount. He needs to pay this and this. That would be the total amount, which would be somewhere near $21, $22. So which of these would give us $22? Let's try this one. $19.50 times 1 and 15. So let's see. 19.5 times 1.15 equals $22.43. There it is. Well, I mean, if you want to double check that, because I kind of skipped that part, you'll just add these. $22.43. $22.43. If you want to know the total amount, you need to have the whole number 1 in with your tip. All right, you can do this, multiply your bill by the tip amount, but it's only going to give you the tip. It's not going to give you the whole price. If you want the whole price of the meal, go ahead and include the whole number 1 and then the tip, 1.15. That'll give you the total price of your meal. The meal and the tip. Okay, problem number 15. Which of the following statements are true? All of these statements have the same corresponding then angles and sides of congruent, similar figures. So I wrote congruent figures. I know they're not perfect, but congruent figures have the same shape and size. Similar figures have the same shape, but different size. Okay? So in congruent figures, everything is equal. Angles are corresponding angles are equal, and also corresponding sides are equal. Well, this is a square, so I could just mark everything. But in similar shapes, you're only going to have corresponding angles equal, because as you can see, they're all 90-degree angles, but the sides are not equal. This side is not equal to that side. It's too short, right? Okay, so let's go through. Corresponding angles of congruent figures are the same. True. Corresponding angles of similar figures are the same. True. So we got here. Corresponding sides of congruent figures are the same. True. Corresponding sides of similar figures are the same. False. As you can see, these sides are not equal to these sides. Well, none of it's equal because I drew it freehand, but I think you get the picture. So the true statements are 1, 2, and 3. Okay, problem number 16. The door on a model building is 3 inches tall. The door on the actual building is 9 feet tall. What was the scale used? All right, everybody wants to go 3/9. Oh, wait, this is inches. And they want to reduce it to 1/3. But no, you have to convert feet to inches before you find out the scale. So how many inches are in 9 feet? Oops, not 12. 12 inches are in 1 foot. How many inches? We know that there's 12 inches in a foot. So let's just multiply 12 by 9. I hope you know there's 12 inches in a foot. 108. Okay, so 9 feet is equal to 108 inches. So in this fraction, we're going to put 3/108. Then we have to reduce that. How many times does 3 go into 108? $36 times. Okay, that's how we get 1 out of 36 here. Make sure you convert feet to inches before completing that problem. Your units must be the same to figure out the scale. All right, problem number 17. Cost varies directly as time. The cost is 12 when the time is 3 hours. What is the constant of proportionality? This one's pretty simple. All you're needing to do is divide 12 by 3, and you'll get 4. All right, why did I do that? I kind of did a little shortcut for you, and I didn't explain what I was doing. So, when something varies directly as something, this is usually the formula they're using. They're using the constant of proportionality formula where y equals k is the constant, times x. In this problem, y was 12 and x was 3. So y equals kx. The y was 12. The k is the constant, and x is the 3 hours. To solve this problem, it has a variable k. To eliminate the 3 by the k, what are we going to do? Divide both sides by 3. This cancels out. This becomes 4. K, or constant, of proportionality equals 4. Okay? So that was short way. That was a long way. That's why you learned that in your unit. Remember, you should memorize this formula. It's the constant of proportionality formula. All right, problem number 18 says convert 20 quarts to gallons. You got to know how many quarts are in a gallon. Do you know that answer? There are 4 quarts in 1 gallon. Okay? I zoomed in too much. Can't see it. Okay. So, well, think about quarters. There's 4 quarters in a dollar, right? So, that should help you remember that. So, to make quarts into gallons, since the quarts, there's 4 of these in one of these, we're going to divide 20 quarts divided by 4 equals 5 gallons. Okay? That was pretty simple. Remember, 4 quarts in a gallon. And don't multiply it if you're going this way. If you're going from quarts to gallons, you what? You divide. If you were going the other way, you would multiply. If you were changing gallons to quarts, you would multiply. But this way, you're going to divide. Okay, problem number 19. Select all of the ratios that are equivalent to 1/5. Okay, let's reduce everything. 2/9 does not reduce. 2/10 does. 1/5. 6/30, that reduces. 6 can go into 35 times. 5 to 20, that reduces to 1/4. 3 to 20 does not reduce. 8 to 40 reduces to 1/5. Check out the ones that reduce to 1/5. Those are your answers. Okay, problem number 20, last problem. Which of the following statements are true about the function y equals 3x? Is it a direct variation? Does it go through the origin? Is the constant of variation 1/3? Ooh, let's do this one. We just talked about the constant of variation formula, remember? Y equals kx. That's the constant of proportionality. The constant is not 1/3. The constant, the k, is 3. So we know that one's not true. So this one's wrong. This should be a 3 because the constant is 3. Okay. Y is 6 when x is 2. All right, let's try that. Y is 6 when 3 times 2. Is that true? 6, yeah, 3 times 2 is 6. So this is true. The function goes through the origin. Do we know what the origin is? The origin is 0, 0. Okay, let's try 0, 0 in this problem now. Y would be is y 0 when x is 0? We have to multiply 3 times 0. What is 3 times 0? Yay, 0. So yeah. If the origin numbers, which are x, y is 0, works in your formula, then it is a function. You say, why wouldn't it? Well, sometimes if they added 1, 0 would not equal 1, right? So, but in this case, it's just 3 times x is 0 equals 0. Okay, last question. Is it a direct variation? This is known as the constant of proportionality, but this formula is known as the direct variation formula. So, since this is set up in this order, that makes this a direct variation. Y is equal to the constant, k, times x. So, is it a direct variation? Yes. The formula matches the direct variation formula. Does it go through the origin? Yes. We use 0, 0, and they equaled each other, and we checked it. Is the constant of variation 1/3? Remember, the constant of variation is identified by the letter k. And in this formula, no. K is a 3, not a 1/3. And is y 6 when x is 2? Yes, we checked that also. 3 times 2 equals 6. Okay. 1, 2, and 4. And we are done.